Light isn't just illumination, Sean. It is the language of the electromagnetic field.
Meet the photon, massless, chargeless, the quantum of light, and carrier of electromagnetic force.
Photons travel at light speed, have polarization and spin, and carry energy in discrete quanta.
Meet the electron, a tiny particle with negative charge, intrinsic spin, and measurable mass. Electrons do not circle like planets. They exist in probability clouds that define chemistry. When photons hit metal, they can eject electrons. The photoelectric effect proved light's particle nature. Compton scattering showed photons transfer momentum to electrons, shifting wavelength in the process. A sufficiently energetic photon can spawn matter, an electron and its antimatter partner, a positron. When matter meets antimatter, they annihilate into photon blips, energy returning to light. Electromagnetic forces act via virtual photons, the messengers exchanged between charged particles. Feynman diagrams picture interactions as particle lines with photons woven between them. Quantum electrodynamics is our theory of light and electrons, the most precise theory in physics.
QED is governed by the fine structure constant, about 1 over.
Precision tests, like the electron's magnetic moment, confirm QED to astonishing accuracy. Electromagnetism arises from a gauge symmetry, descend, a deep mathematical rule that demands charge conservation.
Polarization describes light's orientation pori, a practical property used in sunglasses and 3D cinema.
Scattering makes the sky blue, and radio waves behave differently. Both are electromagnetic interactions with matter.
The electromagnetic spectrum spans radio waves to gamma rays. Different energies, same field.
Accelerating electrons emit synchrotron radiation, a powerful light source for science and medicine.
Magnetism arises from moving charges and the collective alignment of electron spins in materials.
The Stern-Gerlach experiment revealed spin is quantized. Only certain values are allowed. Pauli's exclusion principle forces electrons into distinct states to sterly, the root of atomic structure and solidity. In conductors, free electrons flow as electric current and power our technology.
At low temperature, electrons pair and move without resistance F. Superconductivity enables magnetic levitation. Lasers rely on stimulated emission Fs. Electrons dropping and emitting identical photons in chorus.
LEDs convert electrons to photons. Solar cells convert photons to electrons. Practical photon-electron exchange. Fiber optics send photons across continents, carrying the world's data at light speed. Antennas turn moving electrons into radio waves and back. Thursion, the backbone of wireless communication.
In space, pulsars and quasars blaze across the spectrum with extreme electromagnetic fireworks.
The cosmic microwave background is fossil light heaviest, electromagnetic echoes from the early universe.
Photon detectors convert light into signals, from PMTs to CCDs to superconducting sensors.
Coulomb, Faraday, and Maxwell laid the classical foundations trace, fields and forces in elegant equations. QED quantizes Maxwell's fields charisma. Photons become the quanta that mediate electromagnetic interactions.
Precision spectroscopy and clock tests probe electromagnetic effects to extraordinary accuracy.
From medicine to communications, harnessing photons and electrons reshaped human life.
Electromagnetism builds a bridge from atoms to stars, TEFIC. The same laws, different scales. Photons and electrons grok. Particles and fields met. Two faces of the electromagnetic reality. Next time, we return to the strong force pantheon, the cosmic glue inside every nucleus.
If you liked this, don't forget to like, share, and subscribe so we can keep bringing you more great stories.